Hello, STEM Nation. Jeff here, and welcome to episode number 21 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help ignite students interested in STEM careers. If you like what you hear on this podcast, I ask that you please share it with a friend. Now let's get fired up with our guest, Kaitlyn, and I hope our chat will help ignite your passion towards a STEM career. Kaitlyn Bunker holds a PhD in electrical engineering from Michigan Tech University and works for the Rocky Mountain Institute in Boulder, Colorado, doing energy modeling and technical analysis to complete integrated resource plans in partnership with the Caribbean island utilities and governments. These plans take a whole system view of various options for the future of the electrical sector on each island. Kaitlyn also leads modeling efforts related to small island microgrid opportunities. Welcome to the show, Kaitlyn. Fill in any gaps and share a bit of your personal life.
Thanks very much, Jeff. It's really great to be here. Thanks for having me.
Thanks for being here.
The only thing I'd add, in addition to what I'm working on for work today, is that I'm also an active member in the Society of Women Engineers and really enjoy participating there. And then I'd also share that one of my hobbies is riding motorcycles.
Awesome. Riding cycles, like that. So for STEM Nation, for those that are not familiar with electrical engineering, and I think most of them are, but you got a PhD in electrical engineering, and most people out there probably have a 4-year degree, maybe a master's degree. But can you share some career opportunities with that PhD and what would be available?
Sure, absolutely. So electrical engineering is quite a broad field. So one option would be to focus in things like power and energy, like I've done, and I'm sure we'll talk more about today. Another potential area is working in controls. So a lot of the, devices and systems that we use every day have controls behind them that are likely designed and implemented by an electrical engineer. So that could be things like vehicles that we drive. Another specific example is an electrical engineer I know who sets up the control system for a microbrewery here in Colorado to keep the beer brewing process running and make sure that the output is consistent. So every time they brew a batch, they get the same, quality of beer each time. And so that type of control system engineering could be something that an electrical engineer could do. Another area could be focusing in computer systems. So there's really a wide range, and with a PhD, there's different options too. I decided to go into the nonprofit area and work at Rocky Mountain Institute, as we mentioned. But there's lots of opportunities at things like the national laboratories as well. Just in private industry, there's a lot of folks with PhDs working there. And then, of course, in academia, if you wanted to do research and also teach to students, there's an opportunity to do that with a PhD in engineering as well.
Okay, so we're going to get specific here, and I appreciate that overview. So you're working on microgrids, and it sounds like you're working on the electrical opportunities for some of the islands, which at the time of this recording are still recovering from the hurricanes that came through. Can you delve into your specific area of expertise?
Yes. Absolutely. So I mentioned that within electrical engineering, I focused mostly in power and energy, as well as controls a bit. And when I was in graduate school, I developed a focus in renewable energy and in microgrids, which, just so that we're all on the same page, these are small electricity grids that are using local generation options to meet the local load. And they can operate normally in connection with a larger electricity grid, but can also separate from that grid and maintain operation within their boundaries. So, for example, it could be a specific building or a whole campus that is able to keep electricity running even during a blackout on the grid. So for my PhD, I designed an optimal control system for remote microgrids that utilize different renewable resources. And for my work now, I've zoomed out quite a bit from that level of detail, and I work with a different type of microgrids, island grids, in the Caribbean. And so as part of the Islands Energy program at Rocky Mountain Institute, I have the opportunity to partner with island governments and utilities to design an optimal pathway to meet whatever their electricity goals maybe. So most islands today are utilizing diesel fuel for electricity generation, which has to be imported and is quite expensive. On average, they're paying something like 3 times what we pay for a kilowatt hour of electricity here in the U.S. And so they typically have goals to lower these costs for electricity for their island, while also maintaining high reliability and increasing the sustainability of their islands. And an additional goal that many of these islands have had for quite some time, but is especially driven home after the recent storms, is resiliency. So not just having reliable electricity supply every day, but being resilient to storms like the recent hurricanes that we saw. So they have these great goals to transition their electricity systems, and my team works in partnership with these islands to determine an energy transition plan, to get some early projects moving, and to build capacity in the region so that the knowledge that's being gained through these processes can be shared among other islands as well.
So if you're going to put microgrids onto an island, would an island, let's say like St. Thomas or Puerto Rico, would they be considered one microgrid, or would there be many different microgrids on that island?
That's a great question, and different people use the word microgrid very differently. So in some cases, I've heard it used to describe an entire island, usually a smaller island. But in some cases, people use the word microgrid to mean the island itself. In some of the larger islands, like Puerto Rico or others, there's an opportunity to have microgrids within that island. So smaller pockets of distributed generation that maybe normally are connected to the whole island's grid, but again could separate and provide electricity locally while the rest of the grid is down. So it really could be either of those.
So if the microgrids were already in place and they had the renewable energies, let's say solar and wind, would it be easier to rebuild after a hurricane like they just experienced in Puerto Rico?
Most likely, yes. So certainly those distributed generation resources have to be designed and built in a resilient manner, which is certainly possible to do. So we've seen examples of solar farms, for example, that had very little damage following the storms because they were designed to withstand a Category 4 hurricane. And so that type of design and construction has to be taken into account, first of all. But yes, then with distributed resources that are able to ride through the storm without damage to the equipment, they can typically be started up much more quickly and providing electricity in the local microgrid system, while the rest of the grid may take more time to rebuild and reestablish.
Okay, so could you describe what your typical workday might look like, being in a nonprofit organization working on microgrids?
Sure, happy to. And maybe I'll describe 2 typical days. One would be in the office. So a typical day in the office, I find it to be a really great mix of activities for me. So some of my time is spent at my desk, really working individually, maybe running an energy model for one of our partner islands and looking at how different resources could be used to meet their electricity needs in every hour of the year. Right? So pretty individual technical work, which I enjoy. But then a good amount of my time is also spent in team discussions, and not just check-in meetings where we're providing basic updates to one another, but actual working meetings where we're up on the whiteboard, or actually more often we're using a shared, video screen since our team is spread out over several different locations. And we're working together through a challenge or outlining how to tackle a specific piece of analysis. So that's the second main part. And the third main part of my work is writing. So I get to spend some amount of time writing about our work, both to report on what we're doing to our partners in the islands, and also to share publicly through our blog and other publications that we do. So a week in the office for me is a nice mix of individual kind of technical work, teamwork, and then writing. I'm also fortunate to get to travel to the Caribbean about once a month. And so, as you can imagine, those weeks look quite different than a week in the office. We really make the most of our time when we're there to meet with lots of stakeholders and collect lots of information. We often convene a big meeting to try to get everyone in the same room, all the relevant stakeholders, and get everyone on the same page. And then on the other days that we're there, we'll do some individual follow-up meetings and different site visits. And I do also try to make time to swim in the ocean.
I say, Kaitlyn, you're not fooling anybody. When you're going to the Caribbean, there's no work being done.
It's actually mostly work, and I have photos to prove it of our team in business attire getting a lot done while we're there. But we are very fortunate to get to visit these beautiful places.
Those are all photoshopped. All right. You mentioned something about modeling a system, modeling a power system. How would you actually go about doing that?
Yeah, great question. So first, a lot of it is collecting information. So we have to learn a lot about the existing power system on an island today. And then we can build a base case model. We often use a software called Homer, which is a software for modeling microgrids, essentially. And so in there, we can build a model using the different generation resources that exist today on the island, information about the electricity need, the load in every hour of the whole year. And then we can start to add in different potential resources like solar or wind, energy storage, for example, and add in both sort of the technical side, what is the wind speed resource, for example, and then also the cost side. What does it cost to put in one of these resources and then operate it, as well as things like fuel costs. So we kind of get all of the inputs to the model together and then use this Homer software to be able to run for the whole year in every hour. How would different mixes of resources potentially be able to be used to meet the electricity needs for that island?
All right. Thanks for that, Kaitlyn. Sounds like you got a pretty dynamic work experience there. That's pretty cool.
Yes.
All right, Kaitlyn, let's get specific here. What is one thing that really has you fired up about microgrids or electrical engineering, and where do you see it headed?
Yeah, great question. I'm really fired up by the huge opportunity that we have globally to transition our electricity system to one that is lower cost, highly reliable, and highly sustainable, while at the same time expanding electricity access to those who don't have it today in a way that follows those same principles. We really have much of the technology that we'll need to do that. And I think microgrids will play a big role here. So I'm fired up to see us implement this transition in a way that's beneficial for everyone. And that's really the core of what we're working on at RMI.
So if somebody wants to get into the microgrid area and they're going for electrical engineering, would they have to specialize in their 4-year undergrad, or would they have to go on for a master's and possibly a PhD to be useful in the microgrid area?
Certainly not required to have an advanced degree. If it's something that you really want to focus on and learn more about, that's a big reason that I continued on to grad school. I felt like I was excited to keep learning and dig deeper into one specific area. But to be able to work in the area of microgrids and have an impact, that wouldn't be necessary. If it's, you have an undergraduate degree in electrical engineering and you have the interest, you could certainly get into this field and make a difference there.
Okay, so now we're going to change gears here, moving into an aha moment you've had, something that might help our STEM nation. Can you take us to a moment in time of an incredible aha moment you've had in work or your personal life and tell us the story and how you turn that aha moment into success?
Sure. So when I was in graduate school and pursuing my PhD, I had to take a qualifying exam. And these look different at different universities. For us, this was a written exam first that covered several core areas of electrical engineering, followed by an oral exam with a committee of professors overseeing it. And the more I prepared and studied for the written exam, the more I panicked. Everyone told me that they were sure that I would do fine. And that only made it worse because I was worried about letting people down if I didn't pass on the first try. And I felt like I had just studied electrical engineering in undergraduate, so I felt this immense pressure to succeed on the exam. And that day I was especially stressed, and I am someone who's generally very calm about test taking, but that didn't happen in this case. I remember sitting in class the morning of the exam because it wasn't until the afternoon, and I was sitting there taking these very short and shallow breaths and just really wishing the exam would be over. So that afternoon I took the exam, and, I ended up completely messing up on one of the problems, but overall I passed the exam. And so the aha moment really came afterwards when I reflected back on the stress that I had put on myself when preparing for that qualifying exam. It's certainly really important to study for exams and prepare for big meetings or presentations at work. But I realized it's not necessary and really not worth it to panic or stress yourself out so much. I'd say, nerves are okay to have, but so is confidence in yourself and your abilities. So I've really taken what I've learned from that experience and applied it in the rest of graduate school and now in the workplace.
All right. And if you wouldn't have passed, could you have taken it again?
I could have, yes. You got 2 tries to take the exam. So, I put all that pressure on myself on the first try even, which was really not necessary.
Talking about stress, we're going to move into STEM Nation heading off to college. So they're in high school, heading off to college, probably a little stressed. So Kaitlyn, if you could go back in time to when you were 18, what do you wish you knew back then that would help our STEM Nation launch into college successfully?
So one thing I wish I knew was the value of getting involved in student organizations, which can really be beneficial. I was sort of slow to get involved and wish that I had jumped in a bit more quickly and saw some of the benefits available. Of course, it's really great for meeting other students and connecting with people who have some similar interests to you. But what I also found is that it really provides a great opportunity to build and practice leadership skills in a safe environment. So, for example, in college, I was the treasurer of the Full Throttle Motorcycle Club at Michigan Tech. And then I was also the section president of the Society of Women Engineers. And I continue to have the same opportunity through SWE as a professional, where I can take on a volunteer role and actually be practicing leadership skills at the same time. Potentially making some mistakes and learning from them, but it's a very safe environment to be able to do that in these organizations. And then now I can transfer those skills and be a stronger leader in the workplace.
Adding on to that, so what skills or attributes do you think STEMers need to be successful as they transition from college into their careers?
I would say transitioning into your career, continuing to be willing to learn is the biggest skill you'll want to have. So you'll have a lot of resources at hand, everything you've just learned in college, so a lot of technical know-how, but I certainly was amazed by how much I still needed to learn, even though I was done with the traditional learning of being in school. So coming in with really an open mind and willingness to learn from everyone at your workplace is, I think, what's going to help make that transition really successful.
Absolutely. Lifelong learning. You've heard it time and time again, STEM Nation on this podcast, lifelong learning. And we're going to take a quick break to thank our sponsor, Audible, who's offering a free audiobook. You can head on over to STEMonFireBook.com. That's STEMonFireBook.com to get your free audiobook. And we are going to head into the lightning round. Kaitlyn, are you ready?
Yes, I am.
Okay, so what is the best piece of advice you've ever received?
Enjoy every day. My grandma tells me that every time I talk with her, and it's really good advice. Reminds me to slow down, enjoy today, not just look ahead, or sometimes I get an attitude of, oh, this week is rough. If I can just make it through this week, things will look better. But no, I actually try to follow that advice and enjoy today and every day.
And what is a personal habit that contributes to your success?
Turning off email notifications on my phone. I can still check emails on my phone and read them there if I want to, but I don't get a notification every time one comes in, and that way I don't get distracted or feel like I need to respond to one right away.
And what is your favorite internet resource or phone app and why? And it better not be your mail.
No, it's an app called Asana, which is a task management app. So I keep all of my individual tasks that I need to do for work on there so that I can stay on track with what needs to happen and when. And it's also really multifunctional. My husband and I actually use it for our grocery shopping list. So we can both add items at any time, and then we just check them off when we get them at the store.
And how do you spell that?
Asana is Asana.
Asana. And what is one book you recommend and why?
Hidden Figures. I would recommend both the book and the movie. They're both very inspirational. It was just so cool to learn more about the women engineers and mathematicians that helped put U.S. men and women into space.
Yeah, Hidden Figures, I love that movie. I thought it was awesome when they figured out that, you know what, I'm not going to give it away. Go watch the movie or read the book.
Agreed.
And Kaitlyn, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
Yes, my parting piece of advice is that if you're interested in STEM at all, you should go for it. Because with a degree in a STEM field, you can really work in a whole variety of fields after college. So getting a degree in a specific STEM area really only opens up more opportunities for you. It doesn't limit you to that specific field. So my advice is to go for it, and then your career can evolve over time as you do work that is challenging and meaningful for you while also benefiting the lives of others.
All right. Thanks, Kaitlyn, for all that valuable insight and advice. And with that, we'll say goodbye.
Great. Thanks very much for having me.
All right. I hope you enjoyed our discussion today with Kaitlyn. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. And again, if you're getting value from this podcast, please share it with a friend. Tune in next week where we talk with Katie, who is pursuing a PhD in physics. Until next time, I hope this chat has helped ignite your passion